Last time we did the law of sines. This time we have a law of cosines. You will probably be glad to hear this, but although there is a law of tangents, it's not very common, and we won't be covering it. This section is our last trigonometry section of the year, although trig will be integrated into problems throughout the rest of the year. I went over this in the discussion about law of sines, but you need to be able to recognize when to use the law of sines and when to use the law of cosines. These are the three situations where you use the law of sines, and you are probably still thankful that you don't have to do a full workup of the SSA case here in geometry. These are the two situations that require the law of cosines. You just need to remember them all. And like I said in the law of sines video, there are 5 cases that mirror the 5 ways you can prove triangles congruent, with SSA a special case in both instances. Students will sometimes ask, what happens if you use the wrong one in the wrong instance? If you do try to use the law of sines with SSS or SAS, or you try to use the law of cosines with ASA, AAS, or SSA, it isn't a big deal. But you will just end up with an equation like this. This is what happens when you do the law of sines with SSS. You end up with an equation with too many variables. No matter which two ratios you try to cross multiply, you end up with an equation with 2 variables in it. So that's a clue you should try the other one. The law of cosines is also known as the generalized Pythagorean theorem. Although even though it is known as that, you will hear it called the law of sines more often. We have our regular Pythagorean theorem here that only works on right triangles. But wouldn't it be nice to get rid of that restriction on only right triangles? The law of cosines basically does that. It takes the Pythagorean theorem and modifies it a little bit so that it works on any type of triangle, not just right triangles. When we defined the law of sines, we started out with this triangle here, where the sides are labeled with a lowercase version of the opposite angle. You use this same triangle to define the law of cosines too. Now you can see what the question marks from the last slide were replaced with. You obviously need to memorize the formula, but not all 3. They all follow the same pattern. Use that pattern to help you memorize it. This part is the Pythagorean theorem. These letters get repeated. The outside ones are a pair, a side and its opposite angle. However you want to remember it is up to you, but you do have to remember it. Now let's quickly go back and revisit this idea that the law of cosines is the generalized form of the Pythagorean theorem. Here is the law of cosines, and over to the right I have a right triangle. Let's see what happens to our law of cosines when a right triangle is involved. Since we have a right triangle, we know the measure of angle C, so we can put 90 degrees in for C in our equation. You can check this for yourself on your calculator, but the cosine of 90 is 0, so we can substitute a 0 into our equation. Since that part is a 0, that whole term is 0. We can eliminate it altogether, and we end up with the regular old Pythagorean theorem. This shows you that the Pythagorean theorem is simply a special case of the law of cosines. The law of cosines is the general case that works for all the triangles. Time to look at an example. By this point in time, you have been presented with a lot of different methods for solving parts of triangles. Between Pythagorean theorem, 30, 60, 90 triangles, geometric means, trig, and the rest, you have a lot of options at your disposal. Many times, half the battle is figuring out which of those tools is the right one for the job. Let's assume we didn't know that this was a law of cosines section, and this was obviously going to be a law of cosines question. Most of the time, these clues mean you should be using trig. Not always, but it's a good place to start. This isn't a right triangle, so all of the SOHCAHTOA ratios are out. Thus we either use law of sines or law of cosines. This triangle is in an SAS pattern, so SAS tells us we should be using the law of cosines. So let's do that. We put down the law of cosines. Time to fill in the information we know. Now is a good time to break out a calculator and pause the video to see if you get the right answer before I show it to you. The calculations for this step are these here. Do a bit of adding and subtracting to get this. Take the square root of both sides, and you should get this as an answer. Here's a sneaky tricky part that you need to be careful about. The problem asked us to round to the nearest tenth, so go ahead and fill that part in on your homework, quiz, test, or whatever. But we don't want to use that rounded number for the next part. It isn't precise enough. So either write it down somewhere on your paper, like I did here, or get used to using the memory function on your calculator to save that information so you don't have to type it again. It's just important that you don't use the 50.2 in the next part, as you won't keep enough precision. We now have a decision to make. We could continue using the law of cosines, but by filling in the value for x, we now have an SSA pattern. So we could also use the law of sines. However, it is the dreaded SSA pattern. You know, that one with a ton of issues. And you don't need to know why, at least not yet, but the inverse cosine plays nice with obtuse angles, while inverse sine does not. Taken all together, even though law of sines is an option at this point, it is generally best to stick with the law of cosines to finish off the problem. Inverse sine not playing well with obtuse angles doesn't actually come into play here. It would be fine. But the question is, do you want to remember that little nugget, or just keep with the law of cosines whenever you can, so you avoid that SSA mess? Now that we have decided to stick with the law of cosines, y is next up on the list. This is a good time to pause the video to try it on your own if you want to see if you can do it before I give you the answer. Now we plug in the values we know. You will want to use the full 50.1584299 in your equation instead of the 50.2. You can guess what to do next. Simplify it down. At this point, you should know you need to take the inverse cosine. That will get you this final answer. Did you get the right answer? Did you get the right answer without me telling you? Now you can fill that in. 2 down, 1 to go. And the hard part is done. The last step should be easy. You have 2 angles of a triangle now. You should know how to get the third angle. This last step isn't so crucial for keeping all the decimal places. You can use the 66.3 for this last step, but using all the decimal places certainly won't hurt. Time to fill in the last answer, and we are done.